Okay, hi. My name is Jared. I'm the founder of Achiever's Dream. So today, very quickly, I'm going to share with you how do you do O-level chemistry simple cell. A lot of students confuse it with electrolysis. So at the end of the day, I'm going to do a very quick summary for you on how you differentiate them. But first and foremost, let me help you to do simple cell. Okay, so the outline for today's presentation, the sharing, is to first show you the technique to tackle this topic. Next is to use 3 different examples. And before I give you the summary, I'm going to give you a list of a lot of questions, okay, and answers beside it, and to make sure you really know what to expect from it. Okay, so right now let me move straight ahead. The technique to tackle this question. I'm going to use this example. This is the first example. Okay, the first example I'm going to use will be this. So over here, how do you identify simple cell is by a voltmeter, and usually occurs between 2 different metals. One is more reactive than the other. Okay, so right now let's assuming this is zinc. Okay, this is copper. Okay, and we are being put into electrolyte. Okay, of iron FeCl3 AQ. Okay, where it's concentrated. Okay, so right now what's gonna happen is that I'm gonna link this up. Okay, so at the back of my mind, how do I write the equations? Number 1, I'm looking for equations at anode. 2, equations at cathode. Okay, number 3, I'm going to look at what happened to the pH. Okay, number 4, quickly let me refer. Number 4, I'm looking at any change in observation as well, in concentration. Okay, and lastly is the observations that's made. Okay, so right now, okay, let me put this away. Okay, so right now, always how I learned this is that I use the most reactive metal, okay, and this is going to give out electrons, okay, and in this case it's going to be anode, okay, and it is going to be negative instead of positive. Okay, so I don't like to bring the sign in early when I do the questions. I just want to know that it's anode. Oxidation occurs over here. They are going to lose electrons, so zinc is going to lose electrons. Okay, Zn2 plus AQ, but because it's 2 plus, we need 2 electrons, and we're going to finish it off with this. Okay, Zn2 plus AQ plus 2E minus. That always happens for the most reactive metal. Okay, so this is what happened at anode. Okay, so at anode we can see the observation number 1 is that anode dissolves. Okay, so the electrons over here will move all the way to here. So over here, right, it being a cathode, they're going to accept electrons. So who can accept electrons? You're going to ask yourself this question. So over here, let me tell you what are ions present in this electrolyte. We have Fe3 plus, H plus, OH minus, and Cl minus. Okay, so the 2 candidates to actually accept electrons we have is actually Fe3 plus or H plus. Okay, how about the others? OH minus and Cl minus, they can't accept any more electrons. They can only give away electrons. Okay, so that's why we don't choose these 2. Okay, and between Fe3 plus and H plus, who will accept the electrons? And we will choose the less reactive, okay, which is hydrogen. Okay, next question. Student will ask me, hey, do I have to take into consideration this metal over here, copper? Ask yourself this question. Can copper accept electrons? Answer is no. Because copper, it being a metal, you have to lose electrons in order for it to form Cu2 plus. Okay, you have to lose electrons. That's why they cannot accept at all. So over here, the equation will be 2H plus AQ plus 2E minus gives you H2 gas. Okay, so once you see this, H plus is removed, right, leaving OH minus inside the electrolyte. So what's going to happen is that pH will increase. Okay, so the next thing, since pH increase, this decrease in size, we'll observe bubbles over here because H2 gas is observed. Okay, so with this, I'm going to wrap up. First, you must understand that this is the most reactive metal. Most reactive metal will be anode to give away electrons, whereas copper will accept the electrons being the less reactive metal. Okay, so over here, what happened? Zinc will lose the electrons to give you Zn2 plus. So over here, because we do not express our answer in negative, we're going to put it in the positive side. So this equation we get for anode. And the observation you observe is that it's going to decrease in size. Whereas, on the other hand, copper being the cathode, going to accept electrons. We ask ourselves who's going to accept the electrons. So we have Fe3 plus, H plus to accept the electrons. We do not take copper into consideration because copper cannot accept any more electrons. Okay, so Fe3 plus, H plus, who will accept the electrons? We figured out that H plus will accept the electrons because it is a less reactive metal. Okay, so over here I'll get equation 1, equation 2, okay, observation, and pH increase because OH minus is left behind, H plus is discharged. Okay, so I hope you can understand with this example. Okay, I'm going to move on to another example. Okay, the next example I'm going to use is B. Okay, is B over here. Okay, so I'm going to copy this down very quickly. Magnesium, silver nitrate. Okay, next question, magnesium, silver, and silver nitrate, sorry. Okay, let me quickly draw it for you. V1, 2, 1, 2. This will be magnesium. This will be silver. This will be AgNO3. AQ. Alright. So first ask yourself this question: who is the most reactive metal? Magnesium. So magnesium, being the anode, is going to lose electrons to give you Mg2 plus AQS. But over here it's going to be converted into this way: 2 plus AQ plus 2E minus. Alright, this is the first thing we're going to see. Magnesium is going to decrease in size. Okay, this is the first equation, first observation, decrease in size. Alright, so when electrons come over here, move it to the other side, what happened is that from here it will attract things like Ag plus, H plus, ions over there. So who get discharged? Choose the one that's below the bottom of the reactivity series, and it happens to be silver. So at cathode, silver will accept the electrons to give you silver. That's why this will become bigger. Ta-da! Okay, so since this happened, okay, so you know that this become bigger, this becomes smaller. No H plus or OH minus are discharged, so the pH remains the same. pH remains the same. Okay, there's no change in pH. Okay, so that's it. That's the answer. Number 1, this is the half equation for this one. Number 2, let me complete this. Okay, this decrease in size, this increase in size. This is how you do simple cell. Is it simple? Yeah, that's why it's called simple cell. Alright. Alright, let me go to the third example. Third example, I'm going to use calcium, magnesium, concentrated copper 2 sulfate. Let me show it to you. Calcium, magnesium, concentrated CuSO4. Okay, so quickly let's draw it again. Voltage. Okay, let's draw this again. Calcium, magnesium, we have, alright, we have CuSO4. So we're gonna have Cu2 plus, H plus, SO4 2 minus, OH minus. Okay, so who is the most reactive metal? Calcium. So calcium 2 plus will lose 2E minus, sorry, It gives you Ca2 plus. Okay, but you don't put a negative sign, so you change it. Okay, solid AQ. That's why calcium will decrease in size. Okay, calcium will decrease in size, calcium electrode. Whereas magnesium electrode, what happen when electrons flow from here to here? So who is going to get the charge? Who is going to accept the electrons? So only one of these can accept electrons, the positive charge. So we figured out that Cu2 plus is below, so Cu2 plus accepted the electrons. Okay, so we have this equation, we have this equation. So what's going to happen? You're going to tell us that there's no change in pH because H plus and OH minus, they are not discharged. Number two, you're going to tell me that calcium electrode decrease in size. Okay, number three, you're going to tell me that magnesium, okay, magnesium, there's a brown coating, pink brown coating because of copper. Okay, all right, so these are the three examples that I've covered. So right now, go ahead and try the remaining example. Okay, you can try example D, E, F, G, H, I, J, K, L, M, N, O. I'm practically reading to you everything. Okay, and the answer key is over here for you to refer. I trust my students in the Achiever's Dream, so I give them the answers. So you just have to look it through, practice this, make sure you really understand before you move on. Okay, so I'm going to move on as well to give you the very quick summary. Alright, a quick summary. So for simple cell will be here, electrolysis will be here, okay? Electrolysis, we begin by knowing what sign is what sign because they are attracted to a battery cell. In a battery cell, this is positive, this is negative. Immediately, I know which one is anode, which one is cathode. Okay, and in there, there's electrolyte. Different charges are attracted to different side. Okay, over here, oxidation occurs because they loses electrons, so that's why it's positively charged. So whereas over here is cathode, reduction occurs over here, they accept electrons and they're negatively charged. This part is the same. This is the difference because in simple cell is identified by voltmeter, a voltmeter and two different metals, this metal 1, metal 2. Okay, we will have things like magnesium or probably copper. Okay, whichever is the more reactive one acts as the anode because oxidation occur here, they will lose electrons. Okay, so magnesium will lose electrons to give you Mg2 plus. Okay, to summarize, you get Mg2 plus plus 2E minus to add in the state symbol. Okay, so this is always the case for the more reactive metal, they will dissolve. Okay, and depending on the electrolyte, okay, so over here, for example, let's say we have H2SO4, we have H plus ions and SO4 2 minus. Okay, so over here inside there is only H plus ions, that's why H plus got discharged. This anode, cathode, H plus got discharged, plus E minus give you H2, two of them, so you put 2, you put 2. Okay, so over here if H plus get discharged, the pH will increase. Okay, whereas cathode is actually positive, anode is actually negative. Okay, these are some small difference that you can see, and when I actually show it to you, you will understand. Okay, if you do have any questions, which I believe you will have, do post into the comments, let me know how I can help you. And if let's say you need personal help, feel free to call the number and I'll be a call away, and if time permits, I can jump on a quick call and help you to answer your most difficult questions. Okay, so with that, this is Jared from Achiever's Dream signing off. And if you do need help to discover the secret to get 7 to 42 marks extra within 90 days, let me know. We might be able to be a good fit and I know I can help you out. With that, thank you so much. See you and good night.